Professor. Here's a brief overview of the things you see before the demo. Here's the star and snowflake diagram. This shows the 5 different DIMs that we have, including the audit tables, which is just an audit table with the fact weight list. Here's how the stage database process work, and then this is the data mart with the cube process. I was mainly focused on running the ETL process, creating the cube, and generating the pivot tables for my group. With courses and waitlist being one gigantic table in a database, we have dissected the data to the 4 dimensions: date, class, term, and student. Courses are in the fact waitlist table, but since there are no measurements, it doesn't show up in the pivot table, but it can easily be looked up from the class ID as courses exist per semester with different class IDs. Here's my virtual machine. I had to convert the data from varchar to mvarchar since SSIS preferred the default as mvarchar, and as I've learned throughout the class, changing the data type during the SSIS process is a little complicated, so I did it in the original database. As for the other problem that I ran into was the var binary. As you know, I had to convert that to varchar in order to get it to run properly when I was creating the cube. I utilized the date dimensions from our class assignments as I thought it contains concrete data permanent to dates, and I can just leave out the fields that I do not need in the pivot tables. So here in the iSchool waitlist stage, as you can see on the screen, this process is used to extract data from the iSchool waitlist database, which you have provided us to be loaded into the stage tables. Here you can see that I truncated the stage tables with the SQL statement where I took care of all 5 tables that I would have. And then I ran the data flow from the source, which is the iSchool waitlist database, and all the way to the destination to the class database, stage class, under the iSchool waitlist stage. Here you can see the existing data. It has everything to do with the class, including the dates, class days, class enrollment, if it was a grad class or an online class. After data have been put into the stage tables, users can now transform the data, such as setting the fixed or changing attributes and the historical attributes. Here you can see the DIM students, DIM term, DIM class, and a DIM date, all connected to be into the fact waitlist. Now, all 3 DIMs, the student, the class, the term, all have business keys on the IDs and the keys. So as you can see under the slow changing dimensions, for instance, student ID, the student key are all business keys. This is because they are the primary surrogate key kind of deal. Now, with the slowly changing dimensions, I set the student org, student role, type, and unit to be historical attributes. I had a little bit of fight in my head about this because usually as a student, when you move up a grade, it will change to a different level. However, I thought maybe now with this database, people can load more data into it and keep more historical data for, let's say, if class A is always waitlisted, then we should open up a session. Or if class C is never full, then they should cancel the 3 sessions they have open. So I thought that was necessary for future growth. Now let's jump into the queue process. I was able to run it with the data source setup and the views. I'll show you the view real quick. It has all the keys and IDs set up, all linking to the waitlist table, and then the queue of the iSchool waitlist for the DIM so that I can create the hierarchies. I have then set up the hierarchy to do academic year ID and the name as listed here for the DIM term. I did it because academic year changes once a year, and it's the biggest thing, then leading up to the name of the term, such as fall 2012 or spring 2012. And then there's the ID, which is the unique ID of the term. Here I have the class. I have it separated into 2 different things because I feel like online classes, because they don't have dates and time as here, they should be in a separate session, showing just different, giving the planners a different idea. With the days and time, I feel like maybe on Monday, Wednesday, Friday classes, people will not attend it, will not enroll in this class as much as a Tuesday, Thursday class. So let's say if it's a grad level course, I'm sure not as many people will be bothered by the early morning class as compared to an undergrad student. And so I had to separate it out so that somebody can utilize the data for reporting a little easier. Jumping into the student dimension, I have the setup as the student role, which then unit type and then ID. I think the role of the student is the most important, being whether he or she is a staff member or an alumni retaking some classes for future growth, and then the different level of grade that they are in. As for the date, here's the info on the calendar year, month, name, date of month, the name of week, and full date. I think it was best to keep it very simple, with the key points being on the name instead of just a date with just a number. And the full dates will allow people to see when they were waitlisted more clearly. Here is the pivot tables. As you can see, it's a little complicated with so many data. I have it listed so that I'm only showing you the grad classes with the dates and time for simplicity's sake. Here, as you can see, I have it listed by the course number or class ID, the student, whether they're senior, which department they're in, their IDs, and then the academic information of when they want it to be waitlisted. This side, on the column side, it will be by the dates that they waitlisted, and then somewhere in there will be the data on whether the waitlist is pending or not. I think I have a successful demo of this process, and everything should run perfectly. As you can see that the data do result in good data, and I think that's all. Thank you for a good semester, sir.